So in the previous video, we saw how we combine two fractions into a single fraction, okay, which is a rational fraction. And in this video, we will learn how to decompose a single rational fraction into two or more partial fractions. So let's just recap what are rational fractions. They are fractions in which both numerator and denominator are rational numbers or are polynomials. Okay. Note that the denominator must be a polynomial. However, the numerator can be a number or a constant. For example, these are all the examples of polynomials. Okay, so 1 over 3x plus 1. This can qualify as a rational fraction. Or 2x plus 5 over 3x squared plus 2x plus 1. This is also an example of rational fraction. Or we may have 3x squared plus 2x over x plus 3. This is also an example of a rational fraction. However, 3x squared plus 5x minus 1 over 2, this doesn't qualify as a rational fraction. Okay, so now there are two types of rational fraction. One is a proper algebraic fraction, another one is an improper algebraic fraction. So what do we mean by a proper algebraic fraction? It's a fraction in which degree of numerator is smaller than the degree of denominator. Okay, let me get rid of these writings. And what is an improper algebraic fraction? It's a fraction in which the degree of numerator is bigger than the degree of denominator or greater than the degree of denominator. So that is what improper and proper fractions are. Just get rid of this. Yeah. Now in this video, we will learn about decomposing proper algebraic fraction. Okay, so which means the degree of numerator is always going to be smaller than the degree of denominator. Let's take a look at the cases now. So we have the first case, case 1, which is the degree of denominator is, sorry, we have the case 1 in which the denominator is a linear polynomial. For example, here, the denominator is x and 2x plus 3. Both of these are linear polynomial. So how do we decompose this kind of a rational fraction? Let me write this again. It's 1 over x multiplied with 2x plus 3. Both the denominators have a degree of 1. They are linear. So we can write this because there are two of these. So we write this as a over x plus b over 2x plus 3. We don't need a bracket. We don't need a parenthesis. In case if this had a third linear polynomial, let's say 3x minus 5, we would have included another one here, c over 3x minus 5. Okay, so as many linear polynomials, we'll have that many partial fractions here. Okay. Let's get rid of this for now. So now how are we going to simplify this? Multiply both sides with this complete denominator, x multiplied with 2x plus 3. So if I multiply the left-hand side, 1 over x times 2x plus 3 with x multiplied with 2x plus 3, maybe I can just write it over here. 1 over x multiplied with 2x plus 3, and then multiplied with x times 2x plus 3. I'm just doing the first one elaborate so that you clearly understand what's happening here. A multiplied with x times 2x plus 3 over x plus b multiplied with x times 2x plus 3 over 2x plus 3. Okay. So this x cancels out this x, 2x plus 3 cancels out, and we are only left with 1 here. This one is equal to, this x cancels out this x, 2x plus 3 cancels out with 2x plus 3. So we have a multiplied with 2x plus 3 plus b multiplied with x. Now we've got to find a and b. And we can find a and b by a very simple elimination. Think of what we can substitute as x on both the sides so that either a or b will be eliminated one at a time. Okay. So let's say I substitute x is equal to 0. Now my left-hand side is just a constant, so it will stay as a constant. There's no x over here, so left-hand side stays as 1. In the right-hand side, if I put x as 0, I'll get a times 0 plus 3 plus b times 0. Why did I choose 0? Because I want to eliminate b. 0 multiplied with b will become 0. So I've got 1 is equal to 3a, and that gives us the value of a as 1/3. In the same way, now I want to get rid of b, get rid of a. So let me write a as, let me substitute x as negative 3 over 2. If x is equal to negative 3 over 2, okay, my left-hand side is a constant, it'll stay as a constant, nothing changes. But what happens on the right-hand side? A multiplied with 2 times negative 3 over 2 plus 3 plus b multiplied with negative 3 over 2. Okay, so we get negative 3 positive 3, this whole thing becomes 0. 1 equals to negative 3 over 2b, and that gives us b is equal to negative 2 over 3. So we've got the value of a and b, and we just now need to write the final answer as 1 over x multiplied with 2x plus 3 can be written as a, which is 1 over 3 ax. Remember what we had was a over x. So we have a over x plus b, but b in this case is negative 2 over 3. So plus negative 2 over 3, 2x plus 3. And this can now be simply written as 1 over 3x negative 2 over 3, 2x plus 3. 1 over x multiplied with 2x plus 3 is this. So we took a fraction, one single fraction, and we wrote it as 2 partial fractions. That's our case 1. Let me just tell you one thing. If wherever we are decomposing the partial fraction, if our denominator is linear, the numerator will be 1 degree less. Always, that's a rule. The numerator is 1 degree less than the denominator. Since in this case, the denominator is linear, the degree of the variable x in the denominator is 1. It's a linear. So in the numerator, we just have a constant. Same thing here also. Here, the denominator is a linear polynomial. The degree of the variable x is 1. So the numerator is just a constant. In the subsequent case, we will see how we change the numerator based on the degree of the denominator.